All right, in this tutorial, we're going to go over some greatest common factor and least common multiple word problems. Let's jump right into it. William and Luis are in different math classes at Wyandotte. Luis's teacher always gives exams with 30 questions on them, while William's teacher gives more frequent exams with 24 questions. Luis's teacher also assigns 3 projects per year. Even though the two classes take a different number of exams, the teachers have told them that both classes will get the same number of questions each year. What is the minimum number of exam questions William or Luis's class can expect each year? So let's dissect this problem and first determine if we need to find the greatest common factor or least common multiple. So these two young men are in different math classes. Luis gets 30 questions on each test, while William gets 24 questions on each test. So William 30, Luis 24. Luis's teacher gives an extra 3 projects per year. I don't think that information is going to be relevant for us finding either the GCF or the LCM of the exam questions. The projects is just extra information. So even though they take the different number of exams total per year, the total number of questions will be the same. So in this question, what is the minimum number of exam questions that both of them will take? Minimum is another word for least. So we're going to be looking to find the least common multiple. And of those two numbers, between 24 and 30. So multiples of 24 and 30 are a little bit challenging to do. So let's do a factor tree of both of these. So of 24, we've got 8 and 3. 4 and 2, 2 and 2. So 2, 2, 2, and 3. Then in 30, we've got 3 and 10, 5 and 2. And both of those are prime. So in 24, 2, 2, 2, 3. And in 30, we have 2, 3, and 5. So let's find the ones that are in common between both of these. So we have a common set of 2's right here. We have a common set of 3's right here. And that's it. So with least common multiple, we're going to multiply every unique number. So 2, 2, 5 are all the uniques, and then 1 of each common number. So 1 of the 2's and 1 of the 3's. 2 times 2 is 4. 5 times 2 is 10. 4 and 10 is 40. Times 3 is 120 total questions that they will see throughout the year. Let's go to the second one. Sandra just bought 1 package of 21 binders. She also bought 1 package of 30 pencils. She wants to use all the binders and pencils to create identical sets of office supplies for her classmates. What is the greatest number of identical sets that Sandra can make using all of the supplies? So relevant information is the number of 21 binders and 30 pencils. She wants to use 1 pencil per binder as a set of these supplies for her classmates. And the key word right here in our question is greatest number of identical sets. So that means we're going to be finding the GCF of both of these numbers. And again, multiples of these numbers can be a little bit challenging. So I'm going to do a factor tree again. If you get more comfortable with using multiples, you can do those. The only factors of 21 are 7 and 3. And we've already done 30 up here, but I'm going to do a little bit differently. Instead of 3 and 10, let's do 6 and 5. And then factors of 6 are 2 and 3. So for 21, it's 3 and 7. For 30, 2, 3, and 5. Now our common factors, the only thing that is in common is 3. And that's your GCF between 21 and 30. So the words minimum or greatest, largest, or smallest, other synonyms of those words are really going to be indicative of whether you're finding the GCF or the least common multiple of the given two numbers in the problem.